some practice problems on work and power. So for the first item, we are asked to solve for work. How much work is done by a force of 20 newtons that was applied to push a package of 80 meters along the floor. So we are given with 20 newtons. Of course, that is our force applied on the package. The package was displaced 80 meters along the floor. So using our formula for work, work is equivalent to force times the change in position or the displacement. Work is 20 newtons multiplied by 8 meters. Meters times newtons, that's joules. 20 times 8 is 160 joules. So the work done on the package is equal to 160 joules. On question number 2, we are still asked about work. This time, the object of interest is a block which has a mass of 2.0 kilogram or 2 kilograms. And it was accelerated at 5 meters per second squared. Curious, we are given with acceleration with a distance of 0.5 meters, so that's our displacement, across a frictionless table. We are given a hint here. We have to use the force equation to solve for F. Okay, so this is not a straightforward problem. Work is equivalent to force times the change in position or the displacement. You are given with the displacement but not the force. To solve that, we will use the equation we derived from the second law of motion, which is force is equivalent to mass times acceleration. So mass is 2 kilogram, which is the mass of the block. The block accelerated at 5 meters per second squared. So 5 times 2 is 10 kilogram times meter per second squared is newtons. So the force that is needed to be applied on the block with a mass of 2 kilogram for it to accelerate at 5 meters per second squared is 10 newtons. Of course, this is not the final answer. That is only the force applied on the block, 10 newtons. Multiply that with a displacement of 0.5 meters. So what we get is the force times the displacement, which is the work done on the block, equivalent to 5 joules. Okay, next one. Again, we are asked about the work done, this time by a tractor. The object of interest is a large rock with a force of 5,000 newtons. So we are given with the force at 2 meters per second. Okay, this is not acceleration. Meters per second is velocity. Okay, curious again. We are given with a velocity this time for 2 seconds. We are also given with time, but we are not asked to solve for the power. So we might be using the velocity and the time somewhere else, right? Work is equivalent to force times the change in position. We're given with the force. The change in position, the displacement, we are not. And we are given with a hint here to use the kinematic equation number 4. So don't forget your equations. Displacement is equivalent to the final velocity plus the initial velocity divided by 2 multiplied by time. So the final velocity, you're able to move the rock, right? With the velocity at 2 meters per second. Of course, it was at rest at first. So its initial velocity is equivalent to 0 divided by 2 multiplied by time, 20 seconds. Okay. So my displacement will be 20 divide, 2. 2 divide 2 rather is 1 meters per second multiplied by 20 seconds. So my displacement will be, I get to cancel the seconds. 1 times 20 is 20 meters. Okay, 20 meters. Work force is 5,000 newtons. A large force given by the tractor. multiplied by the displacement of 20 meters. So 5,000 times 20, that's 100,000 joules. Or in kilojoules, divide this by 1,000. This will become 100 kilojoules.